Today our discussion is about dimensionless functions. Now there are three kinds of dimensionless functions that we'll be talking about. The first category are the trigonometric ratios or trigonometric functions. Now in trigonometric functions, trigonometric ratios, that is sine, cos, tan, they are length by length, and length divided by length becomes dimensionless. So trigonometric functions have values which are dimensionless. So sine x equals y here, and y will be dimensionless. Also the angle is arc length by radius as per our definition, and therefore it is length by length again, and therefore the argument of the trigonometric functions will also always be dimensionless. So over here y is dimensionless as well as x, both will be dimensionless. We can take a simple example here. Y equals a sine kx minus omega t. This is actually the equation of a wave. Now in this wave equation, y, a and x all have dimensions of distance, while t is time here, and therefore this quantity inside the bracket is actually an angle and therefore dimensionless. Therefore kx should be dimensionless while x has dimensions of length. Therefore dimensions of k will be dimensionless divided by dimensions of x. Now m0, L0, T0 divided by dimensions of x, and dimensions of x are dimensions of length, and therefore dimensions of k will be L to the power minus 1. There is no m, there is no t. Similarly, logarithmic functions are dimensionless as well. We are not going into the reasons why, because it requires understanding of maths, which you may or may not have at this stage. In logarithmic functions, we have the argument of the log function, that is a by b here, for example, is dimensionless, and the value of the log function should also be dimensionless. So taking an example, x equals 10 log t by a. Here t by a should be dimensionless, and therefore if t by a is dimensionless, t and a have same dimensions, and therefore dimensions of a will be same as dimensions of time, that's t. So that's how you handle logarithmic functions. Of course here y is also dimensionless. Similarly, we have exponential functions. In exponential functions, the exponent is always dimensionless. E is of course a constant, and x is an exponent, variable exponent. This exponent has to be dimensionless. Also the value of the exponential function must be dimensionless. For example, in this expression q equals q naught into e to the power minus t by tau, here t by tau has to be dimensionless, and therefore t and tau have the same dimensions, and dimensions of tau therefore are same as dimensions of time, which is t again. Also because the exponential function is dimensionless, q and q naught have the same dimensions, and q is charge, so q naught also has dimensions of charge. Charge is current into time, and therefore dimensions for charge are ampere into time at. So these are some dimensionless functions, and you often encounter these functions in physics, and therefore it's important that we understand that these functions are dimensionless. Thanks very much.